Okay, so you've got an object moving in the xy plane. Notice it is giving you dx dt and dy dt. And it also gives us at time t equals 1 the position. So this is your really xy coordinate at t equals 1. Okay, part A, I want an equation for the tangent line at the curve 3, 4. So what are the things that we need to write the equation of a tangent line? I need the slope. So in parametric form, dy dx is dy dt over dx dt. And both things are given, so this is cosine of t squared over 2 sine of t cubed. And I want to know what happens at t equals 1, so this is really cosine of 1 over 2 sine of 1. So you could leave the slope like this, or you can type this into your calculator and give me the decimal, up to you. So there's my slope, there's my point, so let's write the equation of the line. There's the equation of the line. Okay. Speed of the object, remember, is dx dt squared plus dy dt squared, the square root of it. So it would be dx dt squared plus dy dt squared. And we want to plug in 2 for t, so just punch this out in your calculator. 2.084 is what I get. Okay, total distance traveled is the integral, and I want to know what happens from 0 to 1 of dx dt squared plus dy dt squared. And I can leave it like this because notice in the original problem they told me what dx dt and dy dt is, right? So just, I would type all of this into y1 into your calculator, and you want to just be in function mode because you only have one variable, and then integrate on your calculator, and you're getting 1.126. Okay, lastly here, I want the position of the object at time t equals 2. So that means the position is your x and y value, okay? But because this is a parametric, I need to do the x separately and the y separately. So think about, how do I get the x coordinate? So we are going to integrate x prime. That will give me my x. I want to know what happens at 2, so that's going to be one of my bounds. And then the only other information they gave us in the beginning was that at t equals 1, the position was 3, 4. So I'm going to use 1 and 2 here. So remember, the antiderivative of x prime is really x, and then you plug in the upper bound, subtract the lower bound. So this is kind of your general equation. We're looking for x of 2, which is the position at time 2. So really, you can move that x of 1 over, so this is really what you're trying to figure out. So you need some form of this equation written. X of 1 is the original x position, which is 3. So that was given up at the top. Let me get rid of this. So this is 3. And then this piece, I'm going to just go ahead and integrate on the calculator. And that will get you to your answer. And you will get 3.436. So if you think about it, this should make logical sense. The final position at 2 is what you started with, the position at 1, and then add on the additional position. It's moving in the x direction. And that's my x coordinate, though. I need to do the same thing with the y coordinate. So 1 to 2 of y prime is the same as y of 2 minus y of 1. Or you could go straight to here. Any version of this equation would be fine. Just use your calculator. And you're going to get that y of 2 is 3.557. So your answer would be 3.436, 3.557.